Hello and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast event. During our event today, our topic will be Catalyst 6800 VSS Quad Sup SSO and Instant Access Overview. My name is Francine Richards and I am a Web Project Manager for the Cisco Support Community. Our expert joining me today is Vivek Baveja, a technical marketing engineer focused on Catalyst 6500 and 6800. He brings more than 17 years of networking technology and management experience across enterprise and service provider verticals. He is currently a technical marketing engineer with Cisco Catalyst series switching products with a focus on backbone, core, and distribution across Layer 2, Layer 3, multi-protocol label switching, DCN, telecommunications, and newer technologies across hardware and software, enabling the enterprise for the next generation of networks. He holds a Bachelor of Electronics Engineering degree. He's a CCIE, and he has a management degree from the Wharton School of Business. Welcome, Vivek. Joining Vivek is Mahesh Nagaridi, a technical marketing engineer also focused on Catalyst 6800. Vivek is also joined by Rose Zhu. Rose is a product marketing manager also focused on the Catalyst 6800. And we also have with us today Samuel Pasquia, who is a product manager for the 6500, 6800 Catalyst. Now, I'd like to briefly outline the format for today's Expert Series event. Vivek will start with his presentation and live demo for the first 60 minutes of the program, and then we will dive into the live question submissions for the remainder of today's event. During our live presentation, you may submit questions to be answered by Vivek and the team of Cisco technical experts using the Q&A box on the right-hand side of your console. The team of technical experts is well-versed in Catalyst 6800, so please begin posting your questions now to give them the best chance of answering them. If you experience any technical issues, please post your question in the chat. We'll be asking polling questions during this webcast, and we highly encourage you to participate by answering them. You may download a copy of today's PDF presentation using the link in the chat window. And now let's go ahead and get started with today's event. We're going to start it off with the polling question. What is your level of experience with Catalyst 6500 or 6800? A, I know Catalyst switching technologies, but I'm not familiar with Catalyst 6500 or 6800. B, I have some experience with Catalyst 6500 or 6800, but I'm not familiar with the architecture. C, I'm running Catalyst 6500 in production, but I have never used a Catalyst 6800. Or D, I'm running both Catalyst 6500 and 6800 in production. So if you can take a moment to answer that, this will give Vivek an opportunity to tailor his presentation more to your needs. Okay, and to make sure to go ahead and submit your questions, as we will answer them a little later in the broadcast. And now I would like to hand the mic over to Vivek, who will give you an overview of Catalyst 6800.
Good morning, good evening, and good afternoon to everyone here. Thanks for joining, and thank you, Francine, for giving me an opportunity. I'm Vivek Baveja, as introduced. I'm working with Cisco for Catalyst series of switches, and let's dive into our focus today, which is a Catalyst 6800 VSS, talking about Quad Sup SSO and Instant Access. So before we dive in, I just want to give you a little perspective of Catalyst 6500, which was launched in 1999. It's been 14 years. The box is up and running in production, basically working on the latest and the greatest technologies and delivering the network productivity. There are very few networking technology products which have lasted that long in this era where we change phones and new technology products every year or two. And what I want to do is take you through a journey of slides here as well as demo to articulate three themes. The first theme is the investment protection you have with 6500, which is already in production for 14 years. We have a roadmap where we are going to have this continuity for next 10 more years with a series of products which we have launched recently, which is 6800 series. So we're going to do a deep dive into each one of them, articulate the value proposition here, and then see the value. The second piece of it, which is as network is becoming more business critical, high availability is a key requirement for all businesses. And I want to articulate a story of high availability with VSS, which most of you probably are already using as I look at the poll. 83% of you are already 6500, so it will be very relevant for them to connect to how we can take the VSS high availability story to a next level, which is hyper high availability with 4 supervisors and 2 chassis. And after that, The third piece, the third message I want you to take away from this presentation is a simplicity story. As we are going in and building more complex networks, we really need to focus in simplifying the networks as well in terms of operations and management. And how can Cisco, with its instant access technology, can help you deliver that while reducing your total cost of operations? That's one of the key requirements we have heard across businesses. So across these three different leaves of messages, I'll also do a demo for you towards the end, which will include our hyper-high availability VSS Quad Sup story, as well as instant access. And feel free to ask as many questions as you want. The main objective here is to make sure you have all your questions answered and have all the information you need when you go back to your businesses to have pretty much the empowered information. Having said that, let's dive in. First is the Catalyst 6800 series. So we launched that in our Cisco Live Orlando in middle of 2013, and there are three different flavors to it. The first flavor of 6800 is 6807, which is a fully scalable backplane modular chassis, which takes the 6500 to a next level. So current 6500 chassis actually scales from a backplane perspective of 80 gig per slot. What 6807 does is basically takes the chassis from 80 gig to 11 times the capacity to 880 gig per slot. The beauty of this solution is that it actually carries the investments you have already made in 6500 today, and you can continue to use those line cards and supervisor in 6807. So taking 6500 to the next level with 6807. Another piece on the portfolio which we have launched recently is our flexible or extensible modular chassis, which is our 6880, which brings higher port density for 10 gig and 40 gig. It brings 80 10 gig ports to the table, including all the rich services you already have on the 6500 with Supervisor 2T. And the last piece of the portfolio which we launched recently is our 6800 Instant Access, which dramatically changes and simplifies the operations for your access layer. What it does pretty much simplifies your provisioning, day zero management, and day end operations and management for access layer switches, everything managed centrally from the distribution 65 and 6800 series. So all of these three bring together or reinvent the 6500 for the next decade. And let's look deeper into each one of them. Before I go further, I want to articulate that all of these platforms bring the rich feature nest of Catalyst 6500 with all the 3200 features you have today going forward, including the service modules. Plus, it also enables your network for a next generation higher port density for 10 gig, 40 gig, and be ready for the 100 gig. And lastly, as you go forward, it'll scale to a higher backplane capacity, giving you scalability in terms of features and long-term switching speed. Let's look at 6807. Think of it as a cube, a 17-inch cube with a 7-slot chassis, 10 RU box, provided with 880 gig backplane capacity. Now, what it brings to the table, the beauty of it is all your 6500 features day one are supported on it. So whatever you are working and using today on Supervisor 2T with 6500 E-Series chassis are available day one because it fundamentally uses the same DNA architecture for 6500. All your line cards, which are 67, 68, and 6900, are compatible with it. There are line cards which are with DFC3 as they are upgraded to DFC4 to be working with Supervisor 2T, simply can be slotted into it. So the simple way to remember for you would be if you can use a line card with Supervisor 2T in your 6500 E-Series chassis, you pretty much can use that on 6807. Kind of articulating the investment protection we want you to take forward here, including the service modules, WISM, NAM, all of those also work in this chassis. So same investment protection story. There has been significant improvement in terms of the architecture and the performance of the system, as you can see with 880 gig of backplane capacity. Plus also there are additional enhancements in terms of power supplies, modular power supplies with 4N+1 redundancy, and also highly efficient fans and cooling system. It has side-by-side airflow, and these are orderable today. So all of this is available today and on Cisco.com. The next piece is the 6880, which is an extensible fixed platform where the Supervisor 2T an enhanced form factor is built onto the chassis itself, so it's built part of the chassis and cannot be removed. It also has 16 10-gig ports built into it. Now you'll also see in this particular platform is that it has 4 semi-modular slots where you are, or half slots you may call it, which actually have capacity to hold 10 or 16 10-gig ports into it. So basically giving you a total of 80 10-gig ports across the 4 half slots and 16 on the Supervisor 2T. In addition to that, as I said, this also brings all the scales and capacity which you already have for Supervisor 2T day one, including all the 3200 features, the scale and performance, all the capabilities in terms of backplane capacity. And also on top of it, your highly efficient fans and power supplies providing you the highly redundant system here. So again, another way for you to take Supervisor 6500 platform into your next generation closet with higher port density and better scale. Again, that is shipping. And the third piece is our Catalyst 6800 Instant Access, which is a 48-port access layer switch equivalent. We call it 6800 IA. Now, the beauty of this is that it acts truly like a line card to your distribution box. So typically, the way we implement access layer, have your Catalyst 2Ks, 3Ks, and 4Ks put in there, being managed separately. What this particular Instant Access client provides you is a capability where your access layer switch doesn't need to be provisioned separately. It can be directly connected by a plug and play, simply powered on, and your distribution box can discover automatically and then provision it automatically. Going forward for the day-end operations, you can pretty much configure your distribution switch to manage all your access layer switches. And you can have a scale of 1,000 ports today, which means you can have 21 access switches today being managed centrally from one Catalyst 6K. It comes in one RU form. It has a stacking capability and can stack up to 3 with 80 gig of backplane capacity in bidirection. It is built with 2 10-gig ports up front for your fabric connection up to the 6K distribution, which will act basically like a fabric trunk to it. And you have 48 1-gig ports, which can be operated in any of the modes across the downstream host ports. In addition to that, it has all the system capabilities which you would expect from a normal access switch. The one key thing, however, I would like to highlight here would be that this is an access client which will work exclusively with the 65 and 6800 series parent and cannot work standalone. But we'll give more details as we go forward inside the deck. And again, this is also shipping available today for you. So, having said that, what you have today is all your 6500 series which are working with Supervisor Sup 720, working with all the line cards listed here with 6700 series and all the modules. What we have brought, the next generation is Supervisor 2T, which also works on all the E-series chassis, but also will work on the 6807 series modular chassis. In addition to that, all the platform line cards with 6700, 6800 series could be upgraded with DFC4 to work with Supervisor 2T by having a DFC4 in it. And all the 6900, the recent line cards, will also support or will work on the Supervisor 2T. In addition to that, all the service modules are also supported here. So the way to read this slide is all the blue ones are supported, all the line cards with blue are supported with our blue chassis, which is a 6500 E-series chassis. All the green ones are supported with 6807 series chassis. So you have investment protection of what you have today. You can continue to use it. If you are running some of the older line cards with DFC3 in it, you can pretty much take the daughter board card out of that box, put in another DFC4 to make it work with your 69, with your Supervisor 2T, and make it work on 6807. Now, going forward, kind of the same story I would like to repeat here in the fact that the Supervisor 2T, the way we are building this investment protection is all the new capabilities and all the new modules and the line cards we are going forward. Not only what we have today, will be working across on both the chassis. So one thing which I want to emphasize again here is that 6500 E-series chassis is here to stay, and 6807 is also there for the better scale and performance you need. And all the investments you are going to see going forward will also work across both these chassis. So key message, 6500 being there for 14 years and will continue going forward, plus it has its own next generation 6807 for higher scale and performance with 880 gig, making the network capacity work for you for next another decade. Now, in addition to that, as I mentioned, there are a few new line cards we are talking about. So with this new scale and capacity on 6807, we are looking at additional line cards with 32 10 gig ports, providing a higher port density across the modular chassis, and 16 10 gig line cards and 8 10 gig line cards. What to also note is that the newer line cards, which are 32 10 gig, will have a higher scale and capacity of 160 gig per slot versus what we have today on your existing E-Series 6500 E-Series with a backplane of 80 gig. So the whole idea of building the infrastructure and making it scale for the future capacity as new line cards come into play. The beauty of it is that these line cards, if you want to use in your existing E-Series chassis, will also work with the capacity of the existing E-Series, which is 80 gig of backplane per slot. Now, these line cards are further flexible. You could use it in multi-speed mode. What I mean by that would be you could also use those in the 10 gig mode or the 40 gig mode with additional adapter or reverse QSFP. So you can pretty much use 4 ports, put the QSFP on it, and bring the 40 gig out of it. So as your network grows, you can start with 10 gig, and as you feel need to go into 40 gig and scale the network further up, bringing in the QSFP into it, continuing to use the same adapter and using a 40 gig out of it instead of 10 gig individuals. All of this across all these 3 line cards. So giving you again the scale, the performance, and investment protection going forward. All of this, what I'm talking about, as I said, these are in production. They are orderable today, and here's a snapshot in terms of scale and performance testing we did on our lab. It is real. It is working, and you can actually whether we have been to one of the Cisco Lives or not, but this is working, and we'll do a demo towards the end of this session too. So let's look a little deeper into our 6880. What you're going to see in 6880 is a higher compact form factor, higher port density, 10 gig, 40 gig ports availability here. What that has done, it has also become a way for us to prove the newer technology here, where we have taken the same supervisor 2T, enhanced in its capability to perform well. So what we have is, sorry, my slide went forward a little. So it has an enhanced capacity in terms of performance and CPU, so the higher scale and performance. There's a dual core CPU there, plus also the 10 gig ports, the 16 10 gig ports are also built into it as a daughter card. So now what you have within one slot, you have a supervisor 2T with enhanced capabilities and scale and performance with 16 10 gig ports. It has all the bells and whistles of existing supervisor 2T in terms of features, as well as access for management and control. Now, in addition to that, it comes in 2 flavors. One is a standard LE form, which can pretty much take care of all the routing table, and the full form, which is the X form, where it can go up to 2 million of the fib table. So if you look at the scale and capacity, that's where the higher performance CPU actually comes into play, because now it can go up to 2 million fib, 1 million for the IPv6. It can go up to 1 million for its MAC flow tables, the net flow tables, and also for adjacencies and MAC addresses. So higher scale and performance with compact form factor, higher port density is the key message here for you. Now, individual line cards. So if you look at the individual half slots, the 4 half slots it has, it also comes in 2 flavors. Again, to support the LE and the large table size. So depending on whichever your needs are, you can use it. If you use a light LE version of it with a higher form or X form of supervisor, the lowest common denominator will work, but each of them can work with either of the combinations. And again, all of this comes with the higher performance CPU and scale performance for your backplane capacity. All these ports, the 10 gig ports, 16 10 gig ports, can work into 1 gig, 10 gig, and 40 gig by having different adapters on it. Again, in terms of shipping, this is going to be ready towards Q1 of FY14. So it's pretty much close to what we are today. In summary, if you look at it, today's Catalyst 6500 and 6800 series really brings to the table higher scale and performance for your fundamental routing and switching capacity needs, with higher scale in terms of MAC table size, in terms of IP routing table size, whether we are talking about IPv4 or v6. It also brings to the table higher MPLS and next-gen solution, including the high availability like VSS and Quad Sup SSO, and also the features which you would need from a QoS and security perspective, especially when we talk about BYOD, where people are bringing in new devices, mobile devices. The wireless piece plays a big role into it, as well as your security for different segments. And the richer media for video, which is becoming more prevalent. You have enhanced multicast tools like MediaNet capabilities for troubleshooting, configuration, and manageability. All of this rich feature set, which kind of encompasses the 3200 features you have today on 6500, are available today also on 6800 day one. The latest release we have today, 15.1.2 SY, so it brings a couple of things in terms of bringing the soul into the hardware 6800. In addition to all the features, I'm going to highlight just the high-level ones, which we'll also have a look at. For the first one is our CampusSec solution, which is the Catalyst 6800 IA Instant Access solution, which brings the access layer like a remote line card. In addition to it, since it's a converged release, what it means is that all the features and capability of the software release which you ran on SUP 720 and SUP 2T are converged here in terms of features and consistency. It also supports MediaNet for SUP 720. So pretty much at par with what you have in SUP 2T. Cisco Discovery Gateway, so that's another Bonjour capability which has become a key for a lot of customers, especially when we have wireless devices like iPhones and iPads looking for printers and everything. One of the challenges in that is where if the network is small enough, like your home network, the Bonjour capability works pretty much beautifully, where you can pass on your screen from your iPad or iPhone to your TV or to your printer and print it directly, because all of them in the same VLAN. Going forward, however, in a bigger campus, all the devices cannot be in the same VLAN because of geography or because of the different security policies. So what Cisco Services Discovery Gateway provides you is capability to jump across VLANs for Bonjour capability, including additional capabilities which scales for enterprise, like allowing the capability to filter services, manage the services which are going to be announced from one broadcast domain to another. Additional to it, as I said, some multicast enhancements, including provided for multicast fast reroute, which further enhances the high availability of multicast network in your network. If one of the path breaks, you have alternate paths with faster convergence time rather than rediscovering the whole multicast path again. Same thing for routing in terms of non-stop forwarding, how to make it further high available even if in times of failure the neighbors do not get reset. So all of these are again some of the highlight key features of 15.1.2 SY, which will work with your existing platforms of whether 6500 or 6800 series, and giving you all the capabilities you need. Again, this is shipping. Key theme here, the first message, reinvented the backbone with Catalyst 6800 series, which is providing you simplicity, higher scale and performance, increased port density, and scale for your next generation network. Let's dive into VSS, which is a high availability story. I don't know how many of you know about VSS and what is the system, so let's do a polling question here to understand where we are in terms of high availability. The first one is, what is the level of experience with Catalyst virtual switching system? A, I'm not familiar with Catalyst single chassis SSO or VSS. B, I'm familiar with Catalyst single chassis SSO, but I'm not familiar with VSS. C, I'm playing the Catalyst VSS in the lab. D, I'm running Catalyst VSS in production. So let's take a couple of seconds here and respond to where we are in terms of understanding of VSS and the system. So while the poll results come out, I want to take a minute here and articulate what is VSS, what does high availability mean, and then we talk about the hyper high availability. This is how we implemented our traditional networks, typically where we had spanning tree run between the distribution and access layer. The red links are the spanning tree links, L2 links, and what you see is typically the loop avoidance spanning tree blocks one of the links. So what you have is a situation where even if you have physical infrastructure, we are using half the infrastructure because half of it is blocked to have loop prevention at L2. In addition to that, what you also see is you would need to have a HSRP or some sort of redundancy protocol at your distribution, so the host at your access layers will have an alternate path in case of a failure of one chassis. The third piece in this traditional network deployment is you will have to go and individually manage each of the access layer switches and each of the distribution layer switches in terms of manageability. Now, all of this adds complexity. So what Cisco brought to the table was the VSS, which basically consolidated your distribution switches into one single control plane. What it means is both your distribution layer switches now acts like a single point of management, where you're going to configure one virtual switch which represents both of them. The data plane for both of these switches will be up, so you're not running any spanning tree anymore. You are doing Ether channel using LSCP or PAGP. And in terms of manageability, you have one. So what you have eliminated is a spanning tree in your network between access and distribution. You have a single representation or single link here, which is logically represented like this. So now you have a single switch at your distribution, logically connected through a single path with multi-links as part of the port channel, and you're using the full bandwidth capacity available between the access and the distribution. So that's what the VSS brings to the table, in addition to the high availability story of a chassis failure. Now, how does it do it? What it does, since it represents a single switch, it's using a single control plane on one of the switch, while the supervisor on the second switch is in a standby mode. And all the line cards in both the standby chassis and the active chassis are managed by the supervisor which is active, one supervisor which is active. In case that fails, the second supervisor, which is in SSO mode, meaning it's completely in sync with its MAC table, routing table, and all the full state of the system, takes over immediately, and the forwarding plane controls continues on thereafter. So you do not lose any network connectivity there. So that's how it provides that's how it provides the redundancy across chassis. Now, it also provides you simplicity in terms of configuration and management of distribution too. So that's what VSS gives you in terms of high availability. Some more details here, as I mentioned here, between the access and distribution. In a typical infrastructure running spanning tree, you would have to configure spanning tree. You would take care of the first hop redundancy in terms of tunings and timings. If you're running a multicast, you would want to make sure whoever is DR, VDR, and how are they announcing it. So all those tunings and capabilities. While you switch into VSS mode, all of that gets away with it. You get a simpler solution in terms of L2 to L4 design with higher scale, higher performance, and higher availability. This particular VSS capability, which is high availability, is available across multiple Catalyst products. Not only Catalyst 6500 and 6800 series, it is also available on your 4500E series with 7E and 7LE and 4500X. So depending on whichever network layer you're talking about, whether it's a distribution, whether it is core, whether it could be access, depending on what switches you use, you can have VSS high availability for you at that point. And again, single point of management and higher scale performance for it. And you don't have to depend on some of the protocol and the tunings and the timings you would have to do to optimize your network, because all of that is built in part of the VSS capability. So while we build the infrastructure for day zero with that capacity to provide high availability across chassis, day end operations also comes into play, right? So with a single chassis, what you have, if the failure in the single chassis happens, you have a network outage, right? And that's the high availability story comes into play, that hey, we need to have something which is fault tolerant, and if there's a failure, one of the ways to achieve that would be having two supervisors in a single chassis. Now, if one of the supervisor fails, you have SSO between failure to supervisor to the other supervisor, and your network is still up. Another way to look would be having two chassis and having all your access devices dual homed to the chassis at the distribution, the two distribution boxes. Now, both of them running VSS in a single supervisor. So if one of those chassis fails, you have the other chassis available for you, pretty much for your network, half the network being up while the chassis comes up. Now, in addition to that, if you want to upgrade your box to a newer release, a code, the two supervisor chassis, if you're not running in VSS or SSO mode, with a mismatched version, will have a network downtime. While if you use the ISSU capability to upgrade, what you can do is pretty much have a stateful transition between the two supervisors to make sure that if one supervisor goes down, the data plane is still forwarding and continues to forward the data without bringing the network downtime. Another way to look at it, if you have dual chassis, which is a recommended design for your distribution switches, using the same EFSU capability, so you upgrade one chassis, the other chassis is still up, while the chassis comes up and the network is still up and restored to higher level with a newer code as you upgrade it. So all of that capability is built in part of the high availability for you to manage your day 0, day N, and operations thereof. That's what the whole idea of VSS and ISSU is from a high availability story. Now let's take a step forward here. So you have a single chassis. When you lose one of the chassis of the two chassis in distribution, you have 50% of the bandwidth available, and that's exactly what is happening in a traditional VSS. If both the chassis are up, traffic is going at 100% as you look into the graph. If one of the chassis fails, what you lose is 50% of the bandwidth. So now the network availability is 50% in terms of bandwidth. Now, this is a traditional VSS, and what we wanted to do was go to the next level of hyper high availability. And with that, what we bring is a situation where you have two supervisors in each chassis, and they are in sync. They are in SSO sync between them, and also SSOs across the chassis. If one of the supervisors in one chassis fails, within 200 milliseconds, it actually converges to another supervisor on the second chassis, on the standby chassis. So you do not lose a 50% of the bandwidth because the second supervisor takes over, and you have pretty much 100% bandwidth available. To have a failure at the same level, you would need 3 points of failure, 3 supervisor failures across the two chassis to even get to a 50% failure point. So it truly represents a very high level of performance in terms of high availability. And we have a demo where we'll do a failover and see the packet loss, which is minimal to none. And again, this is shipping. It's available today. The third piece of the message we have is the instant access, which is the simplicity story, where we want to simplify the operations of our network at access layer from a day 0 and day N operations. And how can we do that? How can we really simplify that? So let's take another polling question here. What is your level of experience with Catalyst Instant Access, which is also called FEX, very similar to data center FEX? A, I'm familiar with Catalyst VSS, but I have no idea about instant access. B, I'm familiar with Nexus FEX, but I have no idea about instant access. C, I'm playing with Catalyst VSS and instant access in the lab. D, I'm running Catalyst VSS and instant access in production. Let's take a few seconds here and respond to it. Let's talk about what is instant access. So as I mentioned earlier, this is very similar to data center FEX. The whole idea is having fabric extension technology between the distribution and access layers so that all the access layer switches appear to be a line card to your distribution box. And it really simplifies in terms of manageability story for you. So let's look at one of the reasons why we want to do it. Again, from a day 0 perspective, as we deploy and provision new access layer switches, to upgrading new existing access layer switches, all the time and money spent on to doing that in terms of resources can be pretty much eliminated with instant access. What it brings to the table would be a plug-and-play capability for your access layer. So let's see how it does it. So again, you're already familiar with your traditional network architecture and how VSS brought a value into it with spanning tree elimination and first-hop redundancy elimination. What Cisco has done is it's extended the same technology of combining the two switches at distribution into one control plane, now bringing also along with it the access layer. So what you see here is the whole access layer switches as well as the distribution part of the single control plane and single point of management. So what it means is, from a 1,000 port perspective, imagine you have 1,021 access switches here and your distribution switches, all of them being managed from a single point of management, single console in. You don't have to console into your access switches to provision or configure in any interfaces. You don't have to, if you have to upgrade your access layer switches, you don't have to individually upgrade new images into it. All of that is done by your distribution layer switch automatically as they are plugged in. You don't have to even console into your access switches because all of that is all of these access switches behave like a line card to your distribution boxes. Now, it also brings to the table not only the single point of management and simplicity story, but it also brings to the table the feature richness of Catalyst 6500 at your access layer. Since the control plane and the forwarding plane resides within the Catalyst 6K, all of that features capability you have today are actually available at your access host port. So if you have a scenario where you want to implement certain features, say MPLS VRF segmentation for your access switches in a routed access, it'll work for you, and it's available to you day one because that capability is available on Cisco 6K. So that's the value proposition of what Instant Access brings to the table. If you are running a routed access, imagine where you would pretty much go into the access layer switch and have routing protocols between the fabric across the access layer and distribution. You do not need to do that for your Instant Access solution because the fabric will take care of it. So let's look a little deeper into what it takes to have the solution implemented. In terms of hardware, what you need is any of the 6500 E-Series chassis or the newer chassis, which is your 6800 series chassis. So you can use either one of them in terms of modularity. Use your existing supervisor 2T. Use your existing 6904 line card, which is a 40 gig line card for 66K, with a 4X adapter, which basically breaks down the 40 gig interfaces into 10 gig ports, and use that to connect to an Instant Access client on its 10 gig uplinks. Key point I also want to mention here is the 6904 line card, which you're already using for a traditional network, whether it's you're accessing your 3750s, 3850s, and 2960s. You can coexist with that today alongside the Instant Access. So your 6904 operating in 40 gig for some of the uplinks to the core. Other 10 gig or 40 gig could be connected to your existing distribution or access switches, and also to the Instant Access simultaneously. All of that can coexist. You don't need to have a separate line card for Instant Access. It uses all the optics in terms of LR, SR, all the traditional optics going up to AR. So the distance between your distribution box and the Instant Access box could be up to 40 kilometers with ER optics. Now, in addition to your 6807, you also have 6880, which is extensible platform, which doesn't need any additional line cards. All the 10 gig ports are actually built in to scale and meet the Instant Access needs in terms of hardware. And all you need to do is plug in with SFP Plus with the right optics, and your Instant Access client would be connected to it. On the Instant Access client, which is a 1RU box, they can stack up to 3. The stacking module is built into it. In phase 1, it will support up to 1,000 ports and stacking up to 3. A little more in-depth into it, all the information in terms of all the parents, what you need, you can go up to 21 switches across 12 FEX IDs. So to achieve a scale of 1,000 ports, you will need to stack and achieve that. We're also looking forward to increase the scale and capacity of this to 2,000 ports in the coming months. So stay tuned for that. You'll see more of it. As we go to 2,000 ports, we also would be able to stack Instant Access up to 5 clients. The key capabilities of your Instant Access client is that it supports not only the back stacking capabilities of 80 gig, then the 10 gig uplink. It supports PoE and PoE Plus. So basically it comes into 2 modules supporting PoE at the front interface ports, and can go up to 24 ports of PoE Plus with 30 watts, or it can go up to all 48 ports with 15 watts. Okay. The configuration simplicity is pretty straightforward. All you need to do is provision a port channel with a mode of FEX fabric to the links which is going to be connected to it. You don't need to configure anything at an Instant Access client. And once this box boots up, it is automatically discovered, and you can start configuring all the host ports of your access layer directly from the disk 6K, including the features of the 6K. So it truly dramatically simplifies it. Now, in terms of stacking, as I mentioned, it can stack up to 3. You can connect any of the host port devices with PoE or PoE capability. And also, what it can do is you can actually make a host port a trunk port. So in cases where you would want to cascade a switch downstream, doesn't have to be a compact switch, you can actually configure a host port on the Instant Access client to be a trunk and connect a compact switch or whatever, and make it use or allow it to pass through BPDU, so you can have a spanning tree across it too. Even smart install, if you wish to choose to have a smart install, take care of your compact switch or the switch which is cascaded. The Catalyst 6K acts as a smart install director and actually will install as this box comes up and put the right image on it as well. Okay, So having said that, let's do a quick demo here and show the whole story about Catalyst VSS Quad Sup SSO as well as the instant access. So Francine, if you could give me a ball, I can share it. I think I already have the ball. So before I go further here, I want to kind of share the network topology. Here is the network topology which we are going to do for the demo, and let me walk you through that, making it full screen. So what we have is two Catalyst 6807 connected with two supervisors in each of the chassis running VSS Quad Sup SSO. We also have instant access clients hanging off it with FEX 101 connected through port channel 101. We have FEX 102 connected through port channel 102. And I'm pushing traffic stream of around 6 gig from a XCR connected to the switch 1 across to switch 2 onto the interface on a 10 gig. In addition, I'm also generating multiple flows across your host ports on the instant access client through the 6807 onto the other FEX client. Another 6 gig here bidirectional. Now on top of it, we also have 6807 here, or 6880, which is the higher port density 8010 gig box. And I'm running a port channel 68 across those two. So these 6880s are also running traditional VSS, not Quad Sup VSS, where the high availability story continues. And another piece we have our 4500X on the right side, again acting as a distribution, also running the traditional VSS. And the traffic stream, again, from these 6880, the XCR traffic 5 flow is going across 6807 onto your Spirent connected onto a switch, which is the 4500X. So that's kind of the topology here. All of the traffic going through the core of the network with 6807 running VSS Quad Sup SSO. So let's look at that first. Another piece to it is that the traffic between the distributions between 4500X and the 6880, we are running different protocols to also demonstrate the non-stop forwarding capabilities which are built into BGP and the OSPF V3 to give the scale and performance of quick switchover without losing the neighbors, and forwarding continues on. So with that said, let's come here. I'll explain to you what this is. So what we have is console in of both the 6807. So this is 6807 chassis number 1 with two supervisors. This is the supervisor 1 and this is the supervisor 2. And this is the second 6807 which is acting in a standby with both the supervisors. So let's look at the first show module for switch 1. So I'm on 6807 and I have two supervisors in line slot 3 and line slot 4. So what we have here, the first window on the top is the slot number 3 and the bottom one is slot number 4 for the first switch 1. For show module switch 2, so basically the right two windows are the switch 2 slot number 3 and slot number 4, and what you have is two supervisors in there for, again, the Quad Sup SSO. Now what you also have here, what you see at the bottom right, where did my mouse go? For some reason okay, there it is. What you have here is another window into the XCR traffic. So what you're seeing is multiple flows. What you see on the top is the flows which are going from switch 1 to switch 2. Also the flows which are going in from the FEX 101 to FEX 102. So all these are the packet transmission and packet receive flows represented in bar diagram. Okay. What I'm going to do is just to show you the representation. For some reason, I think, let me minimize this. My mouse is getting lost here. So let's look at the traffic flows for the traffic going in. So this particular XCI is connected to traffic interface 112, and what you have is around 6 gig of traffic coming in on one of the ports on switch 1 here, and it's going in or going out through the switch 2, which is interface 2/1/12. and 6 gig going out through this. So if you look at the topology here, switch 1 is here connected to 10 gig 1112, where 6 gig traffic is coming in, going across to the switch 2, going to interface 2112 out to the second IXIA. Okay. We also have traffic coming in on the FEX interfaces. So let's look at that. Let's look at show interface port channel 101. And what you're going to see is 6 gig of traffic coming in on port channel 101, going it to FEX 102. What am I doing? Another 6 gig of traffic going on the port channel 2. So again, the flow from 3 to 4 happening on port channel 1, coming in and going out and back. These are bidirectional flows. We also have port channel 68, where the 6 gig of traffic is coming in from the IXIA connected to 6880, coming to 6807 and going to 4500X. So let's look at that now in terms of the traffic. Show interface port channel 68. And we have 68 6 gig traffic coming in.
Hey, Vivek, just a question. We have a question from the attendees. Can you show the CPU load as well?
Absolutely.
Yeah. Thank you.
And we have port channel 45. Again, 6 gig traffic going in there. Now, in terms of the CPU, so I think there was a question of CPU show proc CPU history. So here is the CPU performance. It's below 20% for whatever history you can see of. And I can scroll down further. It has been consistently up and running for a long time. So CPU is stable. The IP process is stable. Now, just to show you that these graphs are real, so what I'm going to do is I'm going to just shut one of the interfaces. So if you look at the flow here, which is the 6 gig traffic going in from 1 to 2, I'll shut one interface down, and what you're going to see is a change in the traffic statistics on the IXIA graph. So let's do that just to make sure you are not seeing this is all camouflaged. Okay, so I'm going to shut this interface, and what you're going to see is a traffic loss here, because the traffic flows are bidirectional. Only one traffic in is coming on the other interface connected to switch 2. Otherwise, all the traffic is gone. So I'll just no shut it, and the traffic will be restored. So the traffic of 6 gig comes back. Same thing for the interfaces on the FEX ports. So if you look at the FEX, show FEX 101 detail, it's connected to the two 10 gig interfaces, and the traffic is coming on one of the host ports of FEX, which is interface gig 101/1/0/1. If you look at it, it's 3 gig of traffic coming in and going in. So I'll just shut it down to show you the traffic flows between two FEXs are also true. So let's look at that. And you'll see the traffic flow here dip, because these are bidirectional flows going, some flows are going between FEX 101 to another interface on FEX 101. So the traffic flow for 3 is not only just to 4, there are some traffic flows from 3 first port to 3 back again, and some flows from 3 to 4. So what I did was just shut some of the interfaces here on 101 and have that. So I'll bring it back again. So the traffic is real, and you'll see the traffic come up again. So all of this 20 gig of traffic flowing into your system. Now let's look at the Quad Sup. What is the Quad Sup setup here? So if you look at show switch virtual redundancy, and I'll make this window big because this is the only window of all the supervisors which is enabled. So I'll just make it big to show you how are these supervisors working, what is the state of each supervisor, and who is going to be the target if I fail this particular supervisor which I'm working on. I'll force a failure here, and we'll see the traffic loss. Okay, so we are on the supervisor. We are on switch 1, slot 3, which is what we are. This particular supervisor is active in terms of control plane and data plane. We have another supervisor on the same switch, slot 4, which is in standby right now. So if you look at it, it's a standby, and it is an in chassis standby halt. So if something happens, it's already in sync with it. Now we have the switch 2 with 2 supervisors. Let's look at that. So we have switch 2 slot 3, which is a switchover target. What it means is that if the active supervisor fails right now, this particular target will take over immediately without any loss. So we are going to see within 200 milliseconds, everything should happen. All these graphs should not see a flicker. And then the second supervisor in the switch 2 is in hot in chassis standby. Okay. So having said that, now what we are going to do is I'll minimize this or adjust this window. So we have all these 4 supervisors. This is the supervisor on the right side, switch 2 slot 3, which is the target as we saw here. Switch over target, switch 2 slot 3. So this on the right side is the switch 2. So as I fail the supervisor here, I'll force a redundancy failure, like there was a hardware failure. The second supervisor will take over and keep an eye on the traffic and see what happens. So here we go. I'm going to force a switch over across. Basically, I'm killing the supervisor on the first switch, slot 3. Let it build it. Here we force it. So what you're seeing is this switch goes down, it goes for a boot. It's like that. This particular supervisor, which was a target, booted up. Or actually not booted up. It was an SSO, became active. And what you're also seeing here is there was no traffic loss. Not even, you didn't see any dip there. So that's the value proposition here. Now if you see the state, all of these are in standby. The first switch is in boot, and your switch 2 slot 3 has become active. So we'll do that. We'll verify now who is going to be the redundancy target again. So we'll do the same, switch virtual redundancy, and I'll make this window big for you guys. So what you're going to see is switch 2 slot 3, which was the target in previous one, has become active, and it has the other supervisor, which is slot 4, is in hot standby for itself in chassis. The switch 1 slot 3 is booting up. Switch 1 slot 4 is now the new target there. Okay, I think I'll have to regenerate it. These messages kind of overwrote the target information. So switch 1 slot 4 is the target here. So we can actually, practically, if you want, I can certainly do it, force another failure, and it's going to make the second switch as the switch 1 slot 4 as the new supervisor here. So let's do that as well and see how it goes. So I've again failed another supervisor, but you don't see any traffic hiccups on the network. That's the value proposition. This is what you see between the BGP, SSO, and new neighbor establishment. It got learned the new routes and came back up. So that's what the hyper high availability. You can still have another failure and still the network would not go down. No change in the traffic. So that's high availability with Quad Sup VSS SSO. I will like to now switch over to another part of the network to show you a simplicity story for instant access. So we'll focus our attention into this area where 6880 is there, and we have instant access client connected 103. So I'm going to console in here and show you how we can provision an instant access switch with a single command on the 6K distribution, and all the switch will be coming up. You can start configuring and playing with it. So I'll switch the console here. So what you have is a 6880, again running in a VSS, show switch virtual. This is a traditional VSS with single supervisor in each, which are built in. I have an access layer switch connected, which is just booted up, it's not there. So if you look at on your 6880, what you have is show FX 103. There's nothing in there. If you do a show run FX 103, there's no information. If you look at the interfaces, for example, if you look at are there any interfaces related to the access switch, which is going to be identified by 103, you would not. So let's look at show IP interface brief, include 103. There's nothing out there other than the port channel. So to enable access or to provision your instant access client, what I've done is I have built a simple port channel. Show run interface port channel 103. So this is a regular port channel. If you do a show ether channel summary 103 summary, what you're going to see is one of the 10 gig links is part of the port channel 103. Okay. Again, just to show you the configuration, this port channel is not a trunk, it's a fixed fabric. So that's one thing you need to configure, the port channel to be fixed fabric. And the second piece I'm going to do is I'm going to just configure a fixed ID. 103 fix associate 103. That's all I do to provision an access layer switch. Okay, and we verify show fix 103 detail. It's connected, and very soon, within 30 seconds, it will be up and running for you. So it's now online. If you look at your access layer switch, it's ready up 103. If you look at the show run FX 103, you have all the interfaces of your access layer showing up now at your distribution. At this point, pretty much I'll do a show IP interface brief. So all your 48 ports of access layer switch is provisioned. You can go in there and you can start configuring IP address, so it's a switch port, so we have to make it no switch port to make it that. Sorry. So you can do a routed, you can do L2, you can do MPLS, whatever you wish to do. Now you have that capability available at your distribution box, because now you're doing the configuration of your access layer switch from the distribution, and you can do verified there it is. So it provides you the simplicity of configuring your access layer. So I'm right now configuring the port 1 of the access layer switch sitting on the 6K directly. That's the value proposition there. Now, not only that, if you can verify that how is the state or the health of it, you can look at it, one of the 10 gig is connected and it's online, the status is up. Now, assuming you want to add another link, so right now 6K there's only one 10 gig connection. If I want to add another 10 gig connection, which is physically connected, I just want to quickly show you how simple it is. If you look at so that's the 10 gig which is connected. All I do is I make it part of the same port channel. And now you have, instead of 10 gig fax fabric between the distribution and access, you have 20 gig, and you can verify it, show fax 103 detail. You have 20 gig bound now. So it's as simple as that to commission additional bandwidth between your access and distribution. This brings me to the end of the whole session in terms of the simplicity story, the three themes which I wanted to walk you through. A, make you feel comfortable in terms of investment protection and the life of 6500E and the 6807 and 6880, which is the next generation. The second piece is your hyper high availability for VSS Quad Sup SSO. There it is for you in terms of providing high performance and scale. And the third piece is the simplicity story, where you can bring your access layer and distribution together into one alongside your Quad Sup VSS like we have done here, and pretty much deploy your network from single point of management and simplicity. With that said, I'd like to stop the share and hand over to, actually we can do a Q&A. Let's go into Q&A right now and try to respond to some of the questions you have.
Okay, thanks, Vivek. Great presentation and demo, and I want to thank everyone for participating in the event polling. We're going to answer some of your questions that you submitted today. If you can't stay with us for the Q&A, please be sure to click on the evaluation link provided in the chat to let us know how this met your business needs and expectations. So our first question here is, can someone address Nexus via 6800 VSS?
So if I understand the question right, Nexus has its own implementation of VSS, which is called VPC. And the way it works is it has two different boxes which are managed separately. So there are two control planes, but both the planes are in sync with each other. What we have in Catalyst is different in the sense that there are no two control planes. Both the switches are managed from a single control plane from one of the switches. And these are two different ways of implementation in terms of how one is used in data center versus enterprise. The VSS is more suitable for enterprises in terms of single point of management, simplicity story, and feature richness, which are required for the enterprise space. And the FEC solution here, the instant access, works. The 6800 IA works with the 6K solution of VSS only, and these are not interoperable.
Okay, and what is the difference between VSS and VPC?
I just articulated that. The idea is two control planes and two data planes, both active on the Nexus 6K or Nexus 5K, or in 6K, Catalyst 6K, where you have single control plane, but both the data planes active across the chassis, and again providing you single point of configuration, single point of management and troubleshooting. Additional to it, what you have is this Quad Sup redundancy as well, which provides you hyper high availability in Catalyst.
What is the difference between VSS and VPC in NXOS?
I think NXOS is the OS which it runs on the VPC on the Nexus platform versus we have iOS. So I think all these three questions are really one question in a way that VPC is the implementation of high availability in Nexus environment, which runs Nexus OS. VSS is the implementation of high availability in Catalyst space, in Catalyst switches, which is with features which are relevant for enterprise. So from a user perspective, from a customer perspective, here is how you need to think about it. If you have a data center where you need hyper high availability, you got to go from a VPC perspective on the Nexus platform, which runs Nexus OS. If you are an enterprise-focused use case where you want to have high availability from enterprise network perspective and the features which are relevant for enterprise being .1x, TrustSec, you're talking about smart installation, simplified operation story, BYOD and NetFlows and other things, then you need to focus on Catalyst 6K product line and use VSS, which runs iOS 15.1.2 as we talked about, and that provides you the single control plane, manageability, and high availability story. Hope that answers the question.
Is 6800 IA used on both 6880 and 6807?
Yes. So the question absolutely is relevant in the sense that, as I said, all of this solution is available today. Instant Access client, the 6800 IA today works with 6500E, works with 6807 today, as with the 15.1.2 as well release. On 6880, it is ready. The next release, which is coming up towards end of March, will also support 6800. So if you have a box today and the release you are running will not support Instant Access, but the next release, which is coming in March, will support Instant Access with 6880 as well.
Okay, and why is the airflow side-to-side, or why are the fan tray and PSUs only serviceable from the front?
Typically in an enterprise space, the wiring closets are small. The access to it from the back is not possible. So access from front is the choice, and the side-to-side airflow is the only way for you to cool. So that's the choice you have. And because the solution is customized for enterprise space, all of those considerations are already taken care of.
And how does the 6807XL get to 880G slot throughput queue? How are new Instant Access clients provisioned, and must any configuration and image provisioning be done at the Instant Access client?
So I think these are two questions. The first is how do we achieve the 880 gig of backplane on the 6807? So the simpler answer is that with the new architecture on the new chassis 6807, what we have done is additional fabrics, additional traces in the backplane, which provides you higher backplane capacity per fabric. So instead of 2 fabric traces, now we have 4 fabric traces per supervisor. So you get total 8. And all of them are working at higher capacity. Instead of 40 gig, they're operating at 80 gig, giving you in total 880 gig across the 2 supervisors. So that's the first part of the question, because it's hardwarely built to give you that performance, and with a higher scale and higher clock speed at the fabric ASIC on the Catalyst 6K, you can achieve that. The other question which you have was that in terms of the images for the instant access client, how can that be managed? Does it need to be provisioned separately, or it is provisioned directly from this Catalyst 6K at the distribution? So the answer is it will be provisioned automatically from the distribution. As you plug in the new instant access client, the client automatically checks with the 6K parent that is it running the image same which is bundled in the 6K. So 6K gets one image which has the image for all the instant access clients as well as its supervisor. And as it sees a new instant access client come up, it'll install that image on it automatically or upgrade it. It also supports the ISSU process, which provides you ability to upgrade one by one your network across high availability environment, including VSS and Quad Sup VSS.
Okay, thank you. And can some ports of the WS-X6904 40G 10G line card be used for the instant access solution and other ports used for traditional network trunk and or IP routed access?
Yeah, so that's a good point in the sense that since you already have a network which is running, you already have access switches like 2Ks, Catalyst 3Ks, and 4Ks running connected to your existing 6904 line card. The real question is, can I have both of them terminate on the same line card? Yes, you can. There is no exclusivity in terms of which line card, or you have a separate line card for instant access mode versus your regular access switches mode. You can have all of them come together on the same 6904. In fact, you can have some ports on 6904 operate in 40 gig, some port operate in 10 gig, and those which are operating in 40 and 10 gig could be in either of the modes for FX Fabric or traditional trunks.
And what is the code upgrade process for an instant access client?
So as I mentioned, you actually have a ISSU process, Enhanced Fast Software Upgrade, which provides you the ability to keep high availability up and running. So when you upgrade with ISSU, one of the supervisors gets upgraded, and during that process, you also have a choice to upgrade each instant access client one by one. So imagine you have access clients across different floors in a hospital. You don't want to have the whole hospital and all the floors go down altogether for a software upgrade. That's not acceptable. So to do that, what you do is you can do an instant access client by client upgrade, going one floor or one wiring closet or IDF at a time, and provision it or upgrade it one at a time. So it provides you that using ISSU run version fix CLI, which is a newly introduced CLI in the VSS set of CLIs.
Thank you. And is PWHE supported?
Yeah, I'm not sure what exactly are we saying, PoE or PoE plus? I think that may be the question. So the instant access client supports PoE and PoE plus. I think that's what the question may be, but I'm not sure if there's something else on that.
Okay. And what is the difference between ISSU and EFSU?
It's an interesting question in the sense that you can debate ISSU is in-service software upgrade versus enhanced software upgrade, where you have a control plane which is not the same in terms of packet loss. So ISSU is where you have pretty much replicated and software upgrade happens hitless. EFSU is enhanced form of that, and that's what the difference is here.
Okay, and can a compact switch be connected to an instant access client?
Yes, which is different than the data center fixes. In a campus environment, you may have requirement of connecting an additional access switch at the downstream of the access client, instant access. You can do that and connect by making a switch port as trunk, as an access port, and allowing all the BPDUs to pass through to the switch, which is cascaded down. Well, the thing to note would be that if you connect a switch downstream, it is going to be managed separately. It's not going to be part of the single management of FX. So that'll be independently managed, and you can use Smart Install and other capabilities to do that. But yes, it can be done. You can allow the BPDUs to pass through and the spanning tree to be enabled on those ports.
Okay, and one final question. We have enough time just for one last question. Why are there only 7 slots, 5 cards, and 2 soup?
So having looked at all the deployments of Catalyst 6K across the industry, there's a significant portion of the users where they have 13-slot chassis or 6509s. What we saw was there's a significant usage of 5 to 7 slots only out of those 9 and 13 slots. That was a sweet spot. Plus also the engineering required to get the same chassis into a higher scale and performance in terms of 880 gig, so you can have investment protection of your existing hardware, got us to the 7-slot chassis. And that's where it is. It gives you the sweet spot in terms of what customers most often use, plus the engineering capability to achieve that scale.
Thank you very much. And that's going to conclude the Q&A portion of today's event. We appreciate your feedback, so please go ahead and take a moment to fill out your evaluation survey, and your name will be entered into a drawing to win a Cisco Press ebook. We had a lot of questions come into today's event, so if you didn't get a chance to get your questions answered, there is going to be an Ask the Experts event coming up that Vivek and Sean Wargo are going to host. So if you have additional questions, log into the Cisco Support Community and click on the Expert Corner tab at the top and post your question on the event. If you have not explored the Cisco Support Community before, go ahead and check out that excellent resource at http://supportforums.cisco.com. And we have a trivia question here that I'd like you to participate in. What do the Euro and the Cisco Catalyst 6000 series switches have in common? A, the Euro was introduced in 1999, the same year the Cisco Catalyst 6000 was released. B, the Eurozone phased out previous currencies in favor of the Euro in 2002, the same year the Catalyst 6000 series was released. Or C, the Euro was introduced in 1997, the same year the Cisco Catalyst 3000 and 6000 series were released. So go ahead and take a moment to answer that trivia question, see if you can get that right. And we have several webcasts coming up in different languages. The first one is in Russian, so it's Advanced Features of Cisco Unified Border Element Configuration and Troubleshooting, and that's going to be on Tuesday, February 11th. And you can register for these live webcasts either on our Expert Corner on the Cisco Support Community, or we'll be posting the links in the chat, the registration links in the chat. So the next one is in Portuguese, and that's going to be on the Cisco Nexus Virtual Port Channel, VPC, and that's taking place Wednesday, February 12th. Our next English webcast is going to be on troubleshooting common features of UCS and Nexus 1000V, and that's taking place on Wednesday, February 19th. Our next Spanish webcast is on the iOS XR, installing and upgrading software and introduction to Cisco Software Manager. That takes place on Tuesday, February 25th. And then we have one final webcast that's in Japanese, and that's going to take place on OSPF Introduction, taking place on Tuesday, March 4th. So again, if you want to register for any of those, check out the link in the chat window. We have some Ask the Expert events coming up as well that are currently running. Troubleshooting Unified Contact Center in Enterprise and ASR 9000 Hardware Architecture. Those will be ending on February 14th. Then we have some upcoming Ask the Expert events, one on Enterprise IPv6 deployment, and that's going to start on February 17th. You can join the Cisco Support Community, where you can share current real-world technical support knowledge with peers and experts. We're also having our presence in social media, so you can visit our community and jump to our several channels from there. We're active on Facebook, Twitter, YouTube, Google+, LinkedIn. We also have a newsletter, and we also have our mobile apps that you can download on both the Android Play Store and Apple iTunes. We have communities in other languages including Spanish, Portuguese, Japanese, and Russian, and we are soon to release the new Chinese community. So look for that. And like I said earlier, you can download our technical support mobile apps from either the Android store or the iTunes store. And be sure to rate the content of your peers on our documents, videos, and blogs on our community and let them know how you liked their content. And now the answer to today's trivia question: what do the Euro and the Cisco Catalyst 6000 series switches have in common? The answer was A. The Euro was introduced in 1999, the same year the Cisco Catalyst 6000 was released. So I want to thank you. Please take a few moments to complete your evaluation. And I want to thank you for attending today's event. This is going to conclude our session. I want to thank our expert, Vivek Baveja, for sharing his expertise with us today. Also, a big thanks to experts Rose Zhu, Mahesh Nagarita, and Samuel Paskia for answering some of the technical